Hi, happy to be here. I'm going to be talking about a very timely topic, which is operationalizing local large language models. And I'm also going to talk about some of the responsibility characteristics of that. So it's going to take a little bit of time to get there. So we have plenty of time. We have, close to an hour here. So I'm going to just very methodically go through all of these core components to get us to the end, which is local large language models. So to start with, let's talk a little bit about my background. Where really I started off my career working in Hollywood, and the reason I worked in Hollywood was because my family had some technology that they would use in order to build different TV shows or commercials, and these are some of the things that I started with early in my career. And I grew up in the Hollywood area, and I got to experience editing and working with live sound, and it was also a really good experience to see an industry that was going through rapid changes. So this was in the 90s, from like 1990 to, let's say, 98. And this was a transition from analog to digital, and it was really good to see that because it helped me with other parts of my career later as I became a professional. I later ended up at Caltech, and what was nice about working at Caltech was I was exposed to many really motivated, intelligent people, really who changed the way I think about things. And I also got experience with Unix systems at Caltech and also the Python programming languages. So this was about 2000. And this also was a good building block to prepare me for the next phase of my career. And then after that, I got involved with live TV and feature film after a few years at Caltech. And this was a period of time where reality TV was really an emerging standard. I spent a little bit of time in that. And a lot of the stuff that I worked on was doing the technical side, so fixing fiber channel systems, or fixing like a switch that went offline so the editors couldn't work anymore. And then all of that really led me towards a period of time where I worked at Disney Feature Animation in Burbank, also Sony Imageworks in Culver City. And really, I was able to combine the stuff I learned as a teenager in television all the way up with the stuff I learned with Unix and Linux at Caltech to the Python programming to do automation. And so I spent a period of my life, let's say up until I was 30, working with automating data engineering systems in film and TV. And so this was before even data engineering was even a word, but that's what the film industry really is it's heavily around data engineering. And then I spent, let's say, another 10 years or so working in tech startups, anywhere from social media to games to building mobile applications. And then about 2016 or so, I decided that I wanted to focus on sharing my knowledge. So I started to build consulting practices, worked with multiple different startups, worked in things like computer vision, also, worked with, building platforms from zero. So a lot of my work was really hands-on, building solutions and showing people how to scale using DevOps, also doing machine learning at scale. And then over the last, let's say, 10 years or so as well, I've been focusing on creating content and building a publishing company. And so currently what I spend the majority of my time on is on a company called Pragmatic AI Labs, and we create content for the largest platforms in the world, including edX, O'Reilly, Coursera, LinkedIn Learning. And so you can see a lot of the topics that I cover are the things that I'm going to cover in this talk. So that's my background, and that's basically how I got here. I also do a little bit of teaching as well. I teach part-time at Duke, also teach part-time at UC Davis. And so let's talk about some of the stuff that is now really on my radar. So the first step, though, in order to get there, we need to talk about machine learning operations and some of the challenges and opportunities, both in the Python language and also in the Rust language. And there's some differences here in terms of the way the world is headed. So first, before we get to that, let's define what MLOps is. And I think there's a lot of confusion about what MLOps is because we want to focus on the fun stuff, which is the machine learning. But in order to do that, we need to think holistically about how to actually operationalize machine learning. And first up, I would call this the rule of 25, which is that you have to think about your company or the organizational practices in a rule of 25, which is that 25% of your time has to be focused on really, DevOps and Kaizen or continuous improvement. How do I make my system more efficient? Are we improving our practices each week? What's slowing us down? Are we Are we in a state of waste? They call it muda. Basically, are we waiting for things to happen? Are we really operating at the level of efficiency we need? And then in terms of data, similarly, are we operationalizing our data? Do we have clean data? Are we using pirated data or illegal data sets and introducing risk? What are some of the things we're doing with data? And then models. If you're doing machine learning, obviously you need models. So you can't ignore some of the things like bias or training methodologies or, being cost effective about how you're training. And then finally, we get to the part that is easy to ignore, which is the business use case, right? Like, are we actually solving a problem that a company needs? So that's really the holistic picture. And so, I would describe this as, again, the rule of 25, and there's no silver bullet. And if you don't have DevOps, you don't have MLOps. And likewise, we're talking about solutions versus experimentation, right? Experimentation is just pure research. A solution is actually something you can use. And also, notebooks are not production software because there isn't a design philosophy around a notebook that makes it reproducible, right? It's reproducible in the sense that someone could run it, but not reproducible in the sense of operationalizing it. A great example of this would be, are they actually deterministic? In many cases, they're not. Can you test a notebook? In many cases, you cannot. There's lots of challenges that notebooks bring. So now we get into, AI operations or operationalizing AI. And so we see a lot of use cases emerging. And so some of the use cases around generative AI in particular that seem like no-brainers are customer service. There could be a lot of benefit to using a large language model or a small language model to look at sentiment or respond to certain things. Also increasing the productivity in coding. I think many people are excited about some of the future possibilities with building solutions around things like GitHub Copilot, AWS Code Whisper, Claude. These solutions can actually give you good results under certain conditions. Content development as well. If you already have pre-existing content, what can you do to leverage that content to create new content or maybe assist you with ideas? And also automation, right? These are some of the things to think about. But really, at the beginning of this, and I think this is where a lot of companies are starting to struggle, is that you have to first look at the base capabilities of your organization. So at the base level is agile or lean methodology. And the agile methodology itself has in some sense a bad name because it's been commercialized and turned into this other industry, but the core concepts of lean methodology have been around for quite some time. And the Japanese automobile industry is a great example of how Toyota has been just tremendous in terms of taking lean methodology and making continuous improvement. So really, that's what we're talking about is doing things in a way that is measured. You're able to eliminate waste. You're able to continuously improve. That's the core. Then the next step is DevOps. But if you don't have those things, you can't really leverage AI because AI is going to be an accelerant. And so in order to really leverage AI, you're going to have to think very deeply about what is the structure of your organization, and can they even leverage AI if they don't have lean methodology built into the culture. So one of the ways that I would start if I was consulting with an organization about how to do this is to think about the core of what's happening on an hourly or even a daily basis in your organization. Like, do you have these productivity techniques built into your organization? And so I'll just talk about some of these real quick, because what I've found in my consulting is that these are things that are missing quite a bit in organizations is just the basics of productivity. And so one of the ways that we can think about this is time boxing. So, oftentimes when you deal with an organization that has substantial problems in producing things in a timely fashion, it's because they're not time boxing. What time boxing means is that you define a task and you say it must be complete in this period of time. Now, that doesn't mean that you're trying to release something that's bad, what it means is that you're defining the task so that it's realistic to accomplish it in a period of time, and then committing to that task completion in that period of time. And this is so powerful. It's very simple, but it's extremely powerful technique. If your organization is not doing this currently, you're going to have real problems using AI. Now, another one is task breakdown, which is related to this, which is that you need to be able to break things down into these chunks. Like a 4-hour chunk, I think, is a good period to break things down. In order to accomplish complex things, like, again, implementing AI in your organization, you have to be able to break the task down that you want to use AI for. If you can't define the task and break it into these 4-hour chunks, you're not going to be able to use AI to its full capability. Task simplification is another one. So it's easy, and I struggle with this even today with lots of experience in this, is how do I simplify the task so that it's actually the root of the thing I want to solve versus unbounded complexity of asking what if scenarios. And then finally, kind of related to this as well, is this concept of commit and iterate. So what this means is that you're committing to do something, and it's okay if it's not exactly what you want, and then you iterate on it. And so the next week you work. And then related as well, I would say, are these concepts of deep reflective work in the era of social media and constant distractions with phones. It's easy to really be caught up in things that are not important, like checking email versus actually doing the 4-hour work that you need to do. And another related technique is this concept of scheduling your day so that you can do a little bit of work, take a walk, think about what you're building, and then maybe finish the second day of work. So these are all things that seem like they're not related to AI, but are related, because if you don't have productivity and you don't have the concept of continuous improvement, you're going to struggle with AI in your organization. And so one of the ways I'd like to think about this is that, if you look at an organization that's struggling to produce things or has real productivity problems, a lot of the problems will be at a simple level defined in the waterfall method versus a dynamic feedback loop. And so if we look at something that does work well with a waterfall or upfront design method, a children's playground. So a children's playground, there really isn't something that's going to surprise you about a children's playground. We know some of the basic safety requirements about how tall to build something so children don't get injured. We know about the materials that we should use. We know about the location where the playground's going to get built. We know potentially how long it should take to get built, who are the people we're going to use. And so you can set up the requirements, you can design it, you can implement the solution, you can verify it, and then you can maintain it. And this is, I would say, essentially the perfect solution for building a children's playground, is to use this kind of upfront methodology, because you should know all these things up front. Unfortunately, software is not like this. It's more like a fig tree. So if you put a fig tree in the ground, there are many different things that are occurring that could play a role in whether the fig is successful. So the weather, it could be how much water is in the ground, what is the temperature outside, are there insects that could harm the fig tree, how much wind is there to really build like a strong trunk. And so in order for a fig tree to be successful, somebody has to be constantly supervising, monitoring, putting in the right location, adjusting to feedback. And that's what software is like. It's more like growing something versus designing a children's playground. And so let's get into a little bit more detail here about how we can now move from the conceptual to the practical. To start with here, I think we should be aware that Python is a very good language for many things, but in terms of machine learning engineering, there's some real problems. It doesn't mean people aren't using it for machine learning engineering, but there's some severe problems that are something that we should be aware of in terms of trying to think about how to make things successful. One of them is the lack of binary deployment. That's really holding Python back, because if you think about so many opportunities that exist in command line tools, for example, and if you don't have a binary deployment, you've really eliminated one of the most useful things you can do with software, which is run it as a command line tool. You've made it much more complex. The other one is the poor performance at scale, like with a CPU. We know that CPU and memory performance is something that Python struggles with. And we also know that there's concurrency bottlenecks that Python struggles with as well. When it was first built, the internet wasn't really at the place that it's at now. Multi-core wasn't really at the place that it's at now. And so concurrency is not something that Python is great at. And we also have this concept of the virtual environment productivity tax, which is related to the lack of binary deployment, where if you have to use Python, you're on one hand, it's nice because it's intuitive. You can look at the code and run it, but there's a huge tax in terms of running Python because you have to remember what Python virtual environment. It's an anti-pattern, essentially, a virtual environment, and also modern security as well. Security is extremely important. By using C as the core language, C itself has huge security problems that other languages have addressed, and then packaging really at the root. So those are some of the challenges and opportunities of Python. So one of the ways we can address this is to think about some of the newer languages like Rust, and in particular for MLOps. I think what it has a strength with is binary deployment, and so binary deployment for Rust is amazing, right? You can just type in cargo build and then you have a binary. And in terms of performance, basically Rust is as good as it gets. It's C-level performance. Also, it has safe concurrency built in. So the language has been designed in a way where it makes it not impossible, but much more difficult to have race conditions because the compiler itself will check for it. And this is why when I hear people talk about, we're going to fix the GIL in Python, and it's like, well, but Python doesn't have a compiler, so why would you introduce something that would make Python even more non-deterministic or unsafe? Right, you potentially could get unintended consequences of adding that capability to Python. And also security, right? Just security itself with Rust because of the immutable variables and some of the security designs. Also ownership model where things go out of scope once you don't use them anymore. These things really have a benefit in terms of the coming era of MLOps and LLMops. So let's look quickly at some of the core concepts of Rust if you're not familiar with it, and this might be a good place to start in thinking about it. It's like, why are people talking about Rust so much, and what are some of the benefits of it? Well, I think one of the key innovations here is that they didn't make packaging like a Perl type approach where, one of the critiques of Perl was that there's more than one way to do it. With Python packaging, there's more than one way to do it, and that's really the curse of Python packaging. With Rust, there's one way to do it. You use cargo, and so it creates the structure where you say cargo new, and it creates out a layout where there's a cargo.toml file, there's a source directory, and you use this convention for many projects, and it can be very simple. You have a library file, you have a main file, and what's nice is that you don't have to really think about it. It's all created for you. Ownership and borrowing as well. This idea of memory safety is built into it from the very beginning. Type and memory safety as well. I think the idea that the type safety isn't important is essentially been debunked, right? It is important to have type safety, memory safety, and then it's essentially automatic to build CLIs here. And so this is the way I would think would be a good thing to think about Rust in terms of what it gives you, is that all these things that are necessary in a real world project are defined for you, and they come with the tool. So it's kind of built in. You could almost say like the standard library of Rust is actually much more complete than the standard library of Python because it includes packaging, which in my opinion should be part of the standard library. Now, one of the challenges though of Rust is that it's much more difficult to write code. It's a more complex language, but one of the ways you could address this is with using generative AI. And there's pros and cons to generative AI, and I'll get into the pros and cons here. But the way I like to think of it is that it's like a trampoline for your code. And so, if you have ever tried to do a backflip and do it on the ground, and you notice that, hey, it's too hard because I don't have the proper technique, I'm close. One of the ways you could perfect this, and this is a common way to learn the backflip, is to go to trampoline, have someone assist you with it, and you could even be in a harness for safety, and then you learn the technique because you're practicing it with something that will give you a boost. And I think that's a good way to think about generative AI. It's something that accelerates a current thing you're doing. It could do the opposite as well, because if you have extremely bad technique, you could get seriously hurt by using the trampoline. So here are some of the things that I see with Rust that are interesting to consider. One of them is that Rust is like eating your veggies. So the syntax is a lot harder than Python. The Rust compiler is extremely mean to you, but those are the negatives. The positives are that you can lean on the cargo ecosystem. So if in a real world project, a lot of your time is with package management, and that's one of the benefits. So it's worth paying the price for that. Likewise, one of the real world problems with code is safety, or the code not working properly. And the fact that the Rust compiler is mean to you is great, especially with hallucinations with generative AI. And so by leaning on generative AI tools, this is one of the ways to really get synergy with this era that we're in of generative AI. But I also want to talk about some of the negatives as well with generative AI. And so I think the bigger one that I see is that I think most people have been a little bit too positive with technology companies, and we should push back a little bit. I think a lot of the stuff that's been happening with generative AI has been really kind of fitting the same model. So if we think about, this is a little bit tongue in cheek here, but a lot of the Bay Area venture capital is really focused on ruthless, profit. And so, in terms of generative AI, it's other people have created copyrighted material, and so you make it, I'll take it. I don't care about the law. Tech startups, we have things like Theranos, who also skirt the rules to make a profit. Crypto, we have FTX, one of the largest, frauds in modern times. And we also have the proliferation of gambling. There's lots of articles. It's been infecting NBA, for example. A player just got banned for life. And you even see that there's other negative things that are happening where universities are used to legitimize the different industries. Ownership can change, when it's convenient for the people involved. We also have regulatory entrepreneurship, which is essentially attacking gray areas that are basically illegal, and then converting those into an industry like the taxi industry, like illegal hotels, illegal taxi, and really pushing people to take a risk. I think an article I read recently shows that something like 1% of Y Combinator companies are successful in terms of a massive exit, and so it could take 20 plus lifetimes for you to achieve that success. But meanwhile, the VCs always are successful because other people are taking the risk while they get the profit. And so that's the downside of being too in love with a new technology, is that there's substantial problems that I think majority of people would want some of these things to be addressed. So we shouldn't just have blinders on when we use generative AI technology. And so let's talk about, now that's some of the negative, but let's talk about some of the positive here of generative AI for Rust. And to start with, what I would say is that one of the things that we can do with generative AI is we can think about the essence of programming. And so a lot of times when you're first learning to program, it's easy to get caught up in what I would call useless suffering. And so debugging runtime errors, packaging systems, syntax errors, boilerplate code, virtual environments, logic errors, development environment setups. This has nothing to do with programming. And so it's easy to get discouraged when you're first programming because all these things are annoying. But really, the essence of programming is just logic, right? It's you take a unit of work, you have it inputted to the unit of work like an add function, and you do a return. So if you understand that, you can program. And there's even optional things that you can get distracted with, like object-oriented programming is optional, concurrency is optional, algorithms are optional, test-driven development are optional, frameworks, Scrum. So that's where one of the benefits, I think, to generative AI is it helps eliminate the useless suffering, and helps mitigate the optional suffering, and helps you more focus on the essential suffering, which you need to be aware of, and something to really think about how generative AI could play out. But as I mentioned, with the caution is that I would say it's easy to just put your blinders on and say, well, everything's the same. And I would call that a false equivalency. But that's one of the weakest forms of argument, is to have a false equivalency, say everything's equal. Well, no, everything is not equal. In fact, the scales of justice, the symbol itself is based on weighing things, right? Weighing two arguments against each other. So, if we look at a simple way to compare offerings is, let's look at the corporate structure. Let's look at the people who are involved in generative AI. Let's look at the capability, right? How good it is as well, and the associated network. So I think that's another way to positively look at generative AI, is that try to pick the solutions that have the capabilities you need, but minimize negative externalities. Because, hey, we live in this world. Why would you not want to pick something that has a minimal risk but maximum reward, versus only optimizing for, hey, this is 1% better or 5% better? I think that's a naive way to look at generative AI. And so we should be challenging companies. Hey, I don't want you to steal people's data. I don't want you to exploit people. I want to use things that have a reasonable set of constraints around what you're doing to negative externalities, but is also successful. And I think that's if that message was propagated more frequently, I think we'd have less problems in tech. So given that, here's the workflow that I would recommend, which is that I found that Code Whisper, the way that they've trained their models, I think fits more with my style of ethics, which is it's trained on internal AWS data. It doesn't appear that there's evidence that Code Whisper is training on copyrighted data sets. And so I feel like AWS Code Whisper is a pretty good solution here. And you could fit that into your model with Cargo, where you could have Code Whisper helping you do code completions. And also it's trained on a lot of Rust code. There's a lot of Rust code in AWS. And you could even have an external chatbot. It could be a local large language model, which we'll get into in a second, like LlamaFile with maybe Phi or something like that. You could also use tools like Anthropic Claude, which I also think has slightly better ethics in terms of the corporate structure and some of the statements around what they're doing. And so you could have these two things where you have all of the basics of generative AI here, which people are using for coding, but also maybe having an external chatbot. So I think we're probably going to see that the development workflow of the future will involve more than just using some simple code completion, is that you need to heavily focus on DevOps. We know that DevOps is critical, right? This concept of continuously testing, continuous integration. So it's even more important in the world of hallucinations. And I would say Rust is a component. And then not just the code completion, but you might want like 1 or 2 or 3 different agents that are helping you assist. And maybe they're even specialized to assist on infrastructure as code or machine learning code or web code. And then that feedback loop really works well together, right? Because you can actually go through and format your code, lint your code, test your code, run your code. And so if you have a very robust language like Rust, I think this is a great style of coding. Okay, so that's what I would recommend for Rust in terms of generative AI workflow. But let's also talk about the Python era a little bit as well in Rust and generative AI. So let's talk about, first some of the success of Python, because I talked about some of the negative, but I also want to talk about what it does well, because it's the most popular language in the world. So if we look at, in terms of data science, what Python is amazing at, I would say the data science libraries are amazing, right? They're very useful. Things like pandas and scikit-learn and matplotlib. All these are really useful libraries. If they weren't useful, they wouldn't be so popular. Prototyping, you can just think in Python and just really quickly build a prototype out. That's one of the benefits of it. API documentation, it's almost like English in the sense that you can go to any different technology company. Likely they have Python API documentation. If you're teaching, simple to use Python to teach because everybody understands Python. It's simple to understand it. And then deep learning libraries. So, but what do we have in terms of there that is a commonality? Is hosted notebooks. So it really feels to me like the hosted notebook, like a hosted Jupyter, hosted Colab notebook. This is the part of Python that is unambiguously good. And it's really hard to argue that it's not very successful. But then I think that's the real key here, is that can we take the good and cap it and put a box around it, and then not do things that it's not good at. And that's where I think the Rust stuff comes in. And so one of the ways I would classify this is that if you think about how successful Python is, you can get more successful than Python, right? Like it's a wildly successful 30-year-old language. And if you look at the features here, they keep going up. At some point, you're going to get diminishing returns, right? Everything that's exponential eventually goes into an S curve. And so we know here that there's intractable limitations, right? True threads, in my opinion, who cares? Performance, packaging. So we may be at the point where, I think the hosted notebooks could be the peak, right, of Python, and that's fine. The peak of Python, I mean, being the world's most successful language, what's wrong with that, right? Like, but I think we should be okay with using other solutions, and so that's really a challenge, is to think about, like, what does less Python and Jupyter really look like? Does it mean more Rust tools and integration? And in fact, we are seeing this. We're seeing tons of Rust tools now develop, polars for data frames, UV for package management. So let's talk a little bit about what you can do with that. And one of the ways you can do this is by mixing Python and Rust together. So I think this is a very interesting way to think about Python and Rust together, is to use Pyo3. And so if you were able to use let's say a function in Rust here, like an add function or something that's computationally expensive, you could wrap it in the Python Fire framework and basically write almost no Python code and have all of the logic be in Rust. I think that's kind of a cool concept, right? So this could be one pattern that you could see. I think another pattern that you could see would be the tooling, right? So we know, again, that people are already shifting to things like rough for linting, polars. I think this is only going to accelerate because of the limitations of what Python has. And so I think we're going to see more and more people really diving into using Rust for things like core tooling even for Python itself. So what are some of the now emerging Rust large language model workflows that we're seeing? So here's some of the things that I've personally experimented with. Would be thinking about these kinds of patterns. So Rust PyTorch bindings are amazing. Actually, they work very well. We also have a Hugging Face Candle, which allows you to take large language models, small language models, and create binaries out of them. So it's trivial. You can use Hugging Face Candle and package them all into a binary tool. We also see things like polars, which, if you combine it with, in this example here, I'm showing AWS Lambda. I think this could be an amazing workflow, right? Is building a data engineering workflow with Rust polars, Rust AWS. You're going to get low memory usage, which is one of the ways you're charged for AWS Lambda. You're going to get millisecond response. It can target even cheaper runtimes like ARM. And it's very simple to even deploy this kind of workflow. And so this is one of the emerging workflows. Even if you're using Python for lots of things, you may want to put pieces of Rust inside of your large language model, data engineering workflow, machine learning workflow, because of how powerful it really is. We also see Lorax is another one, which is, I think, a fork of the Hugging Face runtime for inference. And we see a lot of people using Rust for inference for large language models. So in addition, another pattern you may want to consider is to think about cloud developer workspace advantage as well. And so if we think about, a laptop or a workstation, for example, there's pros and cons to it. I mean, in terms of the con is that it's non-deterministic. It can cost more money. It's not going to be the same development environment. And if you look at things like GitHub Codespaces, AWS Code Catalyst, AWS Deep Learning instances, GCP environments, Azure environments, if you're developing in that environment, you can have deep integration of the cloud tools. You can have the SDK. It's going to be co-located, especially with large language models. You're dealing with terabytes of data or gigabytes of data for the model. Is that you don't have to go back and forth here, and you don't have to worry about those constraints. And so that's one component. And then also the GPU itself. If your laptop has access to the GPU, that's fine. But if you don't, what do you do to work with inference or training? And so this is potentially another workflow we're probably going to see, is that people are starting to use more heavily a cloud-based environment that is optimized for a particular workflow. The one I probably use the most now is AWS Code Catalyst with Code Whisper and or IntelliJ. Those are some of the tools that I personally use. I mentioned a little bit about this as well, this LLMOps with Rust Candle. And so one of the ways that you could work with this would be you have Rust Candle in your GitHub repo, you trigger it with AWS Code Pipeline. So you build out this binary that has the large language model or small language model in it. You do this on a deep learning instance that's already got most of the software configured, and it has GPU runtime. And then you build that binary that is already configured for CUDA, and then you put that binary, let's say, on S3, and then you can invoke it many different ways. You can invoke it maybe a local quantized version, so you could build out lots of different binaries, a quantized binary, a GPU binary, a CPU binary, and run them locally, or you could run them with a spot instance. So I think this is a pretty unambiguously good workflow that most people that are involved with large language models are not thinking about, but that I've tried and I think is a very good way to think about large language model operations. Now, let's also go back again to a little bit of the ethical concerns here now that I've covered some of it, but I also want to go even broader and talk about some of the emerging ethical and market challenges in large language models. So one of them is, forget even whether it's legal or not legal, is to think about things from the world you want to live in. So in the case of ethically sourced data, economically, like what impact is it going to have if there's no way to make money with music, with art, with writing, with other intellectual property? Is that this digital commons, if it's exploited, it's going to de-incentivize people to create art. And what kind of world is that if we don't have ways to help people or incentivize them to create things that we find enjoyable? And then there's another flip side to this, which is ethics. Like, does it even matter to ask someone's consent? If someone doesn't want you to train their model on their art or their book, do they have the right to say, I don't want you to do that? And I would say that consent does matter, and we should be careful about that. And so, as I mentioned before, this is the downside, is that if this proliferates, we could potentially get more and more of this kind of thinking of everything's about just, profit at all cost, and we don't care about the negative externalities. And even further, what it could lead into is this concept of, thinking through artificial intelligence and data science progress, and what's really going to happen. And I think, this is something that we're starting to see more and more of, is that if there's high profit for these large language models, then you see certain things happening. Like people will want to encourage the hype cycle, so they'll make basically false claims about AGI, or artificial general intelligence, that don't make sense. For example, large language model is essentially compressing the internet and doing a prediction on the next word. That has nothing to do with artificial general intelligence. There's no smarts to large language models, but people claim that it's smarter than it is because they want to make it sound better than it is. Like, hey, we have full self-driving car, we have AGI, because it's basically an attempt to do regulatory capture, where if we then regulate AI, only the people that are already successful, the incumbents, will be able to do it. Everybody else can't be able to compete with it. We also see things like, unethical pirating, right, as well. Like all these things happen when it's at that hype cycle, but we're seeing that, in fact, the price of large language model is closely approaching zero because we have perfect competition. And so this happened extremely quick. And I think the takeaway here is to be careful about believing anything from the hype people, because eventually we're going to get to a profit of zero. And if that's the case, why should we be exploiting people or listening to these claims? And so how could we accelerate this process? Well, one of the ways that we could accelerate this process is by really getting more and more involved with evangelizing and spreading large language technology to a broader audience. So what are the training recipes for large language models? How do we actually build these training recipes? What are the binary deployment recipes? Like, how do you actually build things without specialized services or vendors? Also thinking about might isn't right. Just because you could go scrape everybody's YouTube videos and break the terms of service doesn't mean it's lawful, right? Might doesn't equal right. I think a lot of our legal system is built up upon that concept, and we also can think about free and unrestricted models as well. So, what are the ways that we can really propagate these free and unrestricted models so that these true free and open source software can be trained by nonprofits, by universities. If you look at maybe like Google search versus Wikipedia, we see lots of complaints about Google search because it's for profit and the quality is degraded. But Wikipedia, the quality is extremely high, and so many things that are good, a public good, should be open source. And we need to educate the public, Congress, that you shouldn't need a license for something that is pretty intuitively good, especially if it's done in a way that's fair and ethical. And maybe we even need to have model binary mirrors like we did with Linux, where there's not just one location where we're getting all this. Okay, so that's really the background of everything that we need to get to the point of the small language models, which are starting to become very popular. And let's talk a little bit about small language models here and why they're so interesting. Well, in general, what's interesting about small language models is that with large language models, we know that there's all these negatives that have happened. Like people need to cut corners, like train on the YouTube videos because they need more training data, even though it's not legal to. They're breaking the terms of service of YouTube to train on it, and so it basically makes you search for lower quality training data. But with small language models, one of the ways that they work is that they require higher quality training data, and the result of this is that they're going to be much smaller. And so that's going to do things like make it more efficient to train. Maybe you can even train on non-GPUs. Maybe you could train on CPUs or a mixture of GPU and CPU, low resources as well. So you're not going to need like large storage mechanisms or large crawlers to crawl lots of parts of the internet, and easier to deploy. In many cases, small language models work pretty well actually on commodity hardware like a CPU. And so I think that's really the thing that we're starting to see, is that things like small language models potentially could be one of the solutions that prevents some of these problems with this Wild West era of generative AI. Is that one, it's better for the planet; two, it's better for the creators and artists; and then three, it's actually much cheaper, and potentially a model exists where there can be a fair amount of profit, where maybe if you were training on quality training sets, that you're licensing that data and you're paying people, right? Because again, now you've encouraged there to be a creative industry versus just completely destroying it because you could destroy it. So the solution that I would say is one of the better solutions for this is LlamaFile. And LlamaFile is pretty easy to look up. You just Google LlamaFile, and what's nice about it is that it's sponsored by Mozilla. So Mozilla has got a great reputation for building things like Firefox, for example. And you can download it. Just do chmod plus X. You can take a large language model, a small language model, run it locally, and there's really nothing to do. So I think if I was going to point someone into a direction of where they could test out a small language model and or an open source model, I would say LlamaFile would be one of the best choices to play around with, and pretty easy to get started. Really, there's not much to even explain with it. So that's it for my talk here. I have some links here to other resources like the Rust Candle Cookbook, Rust MLOps template, Rust Data Engineering repo, Rust Python repo, Rust AWS Lambda repo, some Duke Coursera courses as well around this. These are all places that you can take a look at some of the stuff I've done. Also edX as well. If you look up Pragmatic AI Labs, we have a lot of content around this as well.